Here's one for you to try. It says find the equation of the line tangent to y equals x plus tan x at the point pi comma pi. So you have all the tools to work this out. Pause the video and see what you come up with, and then we'll compare notes. Okay, well remember that the equation of the tangent line, the equation of any line, is given by y minus y1 equals m times the quantity x minus x1, where y1 and x1 are actual coordinates of a point, and then the y and x stay as variables. So look, right off the bat we can see we have x1, y1 given. So we know x1 is pi, y1 is pi. Now m, that's going to be the derivative, f prime, evaluated at the point, well, let's write it as x prime of x, find that derivative and evaluate it at the point x equals, well, we're interested at what happens at x equals pi. So at x equals pi. Okay, so everything's already coming into view a little bit. What we really need is that derivative. So let's take the derivative. I said f prime of x, we'll write here as y prime equals, okay, derivative of x is 1 plus the derivative of tan x, if you recall, is secant squared x. That's something you should be setting to memory soon if you haven't already. Evaluated at the point x equals what? X equals pi. Well, maybe you don't know what secant pi is and you're reaching for your calculator. Don't do that just yet. How about we rewrite it as 1 plus 1 over cos squared pi. Well, cos of pi is -1, so we have -1 squared. So 1 plus 1 over -1 quantity squared gives us 2. So there is the slope of our tangent line at that point. Now we can plug this all into our equation of a line and get that worked out. And remember to present your lines in slope-intercept form. That's the y equals mx plus b form in the final answer. It's just a better way to think about it. More concise, at least. Okay, so we have y minus y1, which is pi, equals m. M, we decided m was 2, x minus x1, which was also pi. There we go. Now we just clean it up. It's all algebra from here. So I'm going to distribute this 2, and then I'm going to add this pi to both sides. So we have y equals 2x minus 2 pi. Look at that. This really comes out nicely. Plus pi. So finally, y equals, how about 2x minus pi? That ought to do it. Let's give this a quick look in Desmos just so we don't lose track of what we're actually computing here. Okay, well, here we go. We're in Desmos here, and I've graphed in red the function x plus tan x, and then in blue I graphed 2x minus pi. That is our tangent line, and I went ahead and labeled the point pi comma pi. So there's a lot going on here, but note that if we just focus in on the point pi comma pi, you can see that the red is the tangent, and then right at this point we have this tangent line 2x minus pi. So it just hits the graph at that one point. And imagine, I mean, we'd have a lot of different computations to do to get the tangent lines at other points, right? There's a lot of vertical asymptotes and a lot going on here, but we're only interested in pi comma pi at this juncture. So when we focus on that one point, we get a single tangent line, no problems.